Hello everybody. Now we are going to see what is set theory. The next lesson is set theory. So just look at the set theory. First we have to know what is set. Set means it is a well-defined collection or class of distinct objects. The objects in a set are called its members or elements. So let's look at the example to understand more about set. In set A is equal, curly brackets open, the elements are 2, 4, 6, 8, curly bracket close. This is a set A. In set A, the elements are 2, 4, 6 and 8. The main thing we have to care while writing the set are the elements in a set should not be repeated, and each elements in a set have to be separated by commas. So here set A contains 4 elements, all are separated by commas, no element should be repeated, and the elements are closed and opened in curly brackets. So this is the set. This group is called set. Next, there are two methods of describing set: tabular or roster method, rule or set builder method. So first we have to look at the tabular or roster method. In tabular or roster method means it is the normal way of writing the set. It is the normal way. We already previously see the set A contains 2, 4, 6, 8. That is the normal way of writing the set is called tabular method. Here set Z include 98, 56, 78 and 8. Set X include A, B, C, D. So it is the just writing the normal way of writing set is called a tabular method. Next we have to look at the set builder method. In set builder method means it is a set by only stating certain properties which its members must satisfy. It includes, in tabular method we just stating the set, but in set builder method we have it to be descriptively writing what contains in a set. For example, in set V contains A, E, I, O, U. But in set builder, that is tabular method. But in set builder method, we will write V is equal to X such that X is the vowels in alphabet. So when we see the set V is through the set builder method, we can understand what is in that set. So we can understand that that is the vowels in a alphabet. X such that X means X represent the whole set V. In the second X represent one of the elements in a set A. So in whole set X, one element A is the vowels in a alphabet that represent a set builder form. Another example, address, that is a word. In a tabular method we can write it Z is equal to A, D, R, E, S. The D and S are repeating, so we should not be repeated in a set. So in set builder method we have to identify that what is ADRS. So ADRS is a letter from the word address. So we can represent it as a set builder method. That is the set builder method. Next, this is the basic theory concept relating to the set. What is set? The main things we have to be care while writing the set. Two methods of set, tabular and set builder method. Then we have to go to the pictorial representation of the set. That is called Venn diagram. Through the Venn diagram we are pictorially representing the set. It is the pictorial representation, and we are using rectangle and circle for the pictorial representation. Let's look at the pictorial. There are 5 major set operations: union of two sets, intersection of two sets, difference of two sets, complement of two sets, disjoint set. These are the main set operation relating to the pictorial representation. These 5 set operations have a respective pictorial representation. First one is union of two set. In union of two set means combine all elements in two set. We are available two set or three set. and combining the all elements in a 2 or 3 set. For example, set A include 2, 3, 4, 5. B include 3, 5, 7, 8. So combine the elements in A and B. So A union B. The sign representing union is U. So we can written as A union B is equal to 2, 3, 4, 5, 7, 8. Because in A and B there are common elements 3 and 5. So we should not repeat in the union set. So first we written the 3, 5. Then we write the 7, 8. 2, 3, 4, 5, 7, 8. The pictorial representation is A. Circle A represents set A. Circle B represents set B. So they are combining. So that is the union of two sets. Next one is intersection of two sets. Intersection of two sets means in set A and set B, all elements which belongs to set A and also belong to set B. The common elements are representing to intersection of two sets. In both set, some elements will be same. So such elements will be representing through intersection of two sets. For example, A. Set A 1, 2, 3. B 1, 3, 5. So the common elements are 1, 3 are repeating in both set. So A intersection B is equal to 1, 3. The pictorial representation A and B, two circles representing set A and B. The shaded part in A and B there is an intersection part that will be shaded in this picture. That is the intersection of two sets. In that part we can return 1 and 3 because that is the intersection part. Next is the difference of two sets. The difference of two sets means in set A and set B, all those elements which belongs to set A but not belongs to set B. In difference in two sets means we are considering two sets A and B. A minus B, that means A difference. A minus B means A difference in B. That means the elements which belongs to A but not belongs to B, that will be the A minus B. In A and B, the set 1, 2, 3, 4, 5 in set A. In B, 2, 4, 5, 6, 7. So A minus B minus the elements contains in A but not contained in B. Let's look at it. In A, first element is 1. 1 contained in A but not in B. So A minus B, first element is 1. Then 2. 2 contain both. 3. 3 contain A but not contained in B. So A minus B, another element is 3. 4 and 5 contain in both set. So in A minus B, we are giving importance to A. What is belongs to A not belong to B. In B minus A, we are giving importance to B. What belongs to B not belongs to A. Next is B minus A. So we are giving importance to B. Let's look at the B set. 2 contains both. 4 contains both. 5 also contain in both. 6 and 7 contain in B but not in A. So 6 and 7 is the B minus A. So giving importance to B, what are included in B but not in A, what are the different, is written as B minus A. So the first part given the importance A minus B, A will give importance, B minus A, B will give importance. The pictorial representation is that A minus B. In the A and B circles, so the intersection part is pink shade and the different A minus B, the different part is 1 and 3 is representing through the green part. B minus A is representing by yellow part. So the difference, that is the difference of two set. Then complement of two set. Complement of a set A is defined as a set contains the elements present in the universal set but not in set A. The universal set means all the subset to be attached to a fixed large set. That is large set is called a universal set. So The elements are contains in universal set but not in a set A. That is called a complement of 2 set. The universal set is called 2, 4, 6, 8, 10, 12. In set A contain 4, 6, 8. So the complement set are the elements contains in universal set but not in A. 2 contains only in universal set, not A. 2 is the first step. 4, 6, 8 contains in both. 10, 12 contains only in universal set, not in A. So 2, 10, 12 are the universal complement of 2 set. Contains in universal set but not in set A. So the set A is representing to the yellow shade and universal set is the rectangle. So that is the complement of 2 set. Next one is disjoint set. Disjoint set means a pair of set which does not have any common elements are called a disjoint set. The disjoint set is very simple, that is only the 2 sets but not elements are common. All elements are different. In set A 2, 3, set B 4, 5, there is no intersection, no connection between 2 sets. So these are representing like that, separate 2 circles, there is no intersection. These are the main set operation: union, intersection, complement, difference, complement, disjoint. 5 set operations. Next we are going to look at the main equation or theory of set. That's the main theory of set. That is the equation. If the equation is success, our set operation will also be success. So the equation is n number of elements in A union B union C is equal to number of elements in A plus number of elements in B plus number of elements in C minus number of elements in A intersection B minus number of elements in A intersection C minus number of elements in B intersection C plus number of elements in A intersection B intersection C. That means a number of elements in A union B union C means the common, when we are comparing the 3 set, the number of elements in combining the 3 set, that is representing first part. Then number of elements in A means number of elements in set A. B, number of elements in set B. C is number of elements in set C. N and A intersection B. A intersection B means we are considering A and B sets and the common elements in A and B, that is the A intersection B. A intersection C, considering A and C set and find out the common elements. B and C, the common elements in B and C. A, B and C, the common elements in 3 sets. So let's look at the example. There are 3 sets A, B and C. First we have to find out A intersection B. So A intersection B, A and B are considered. The common elements are 2, 3, 4. Then A intersection C. The common elements are 1, 2, 4. B intersection C. Common elements are 2, 4, 6. So the A intersection B intersection C. The common elements in both in three sets are 2 and 4. So when we apply into this equation, the A union B union C are 6. When combining the 3 all sets, we will get 6 is equal to number of elements in A 4, number of elements in B 5, number of elements in C 4 minus A intersection B is 3, A intersection C is 3 and B intersection C is also 3 plus A intersection B intersection C is equal to 2. So we will get 6 is equal to 6. So we can say that the theory is right. That is the pictorial representation of it. We are drawing 3 set A, B, C. The way of writing is like this. Then first we have to write the common element in 3 set. The common element in 3 set will write in the intersection part of 3 sets. That will be in the picture. You can see the part in that picture. The first we will write the common elements in 3 sets in 2 and 4. Then we will write the common elements in A and B, that is 3. Then we will write B, A and C, that is 1. Then we will write B and C, that is 6. Then we will considering, and after writing all these intersection, first we will write the common intersection in both. Then we will write that intersection between each set, A union B, A union C, and B unions A intersection B, A intersection C, and B intersection C. After writing all these, we will consider in each set separately. First we will consider set A. In set A, 1, 2, 3, 4 are the elements. When we consider the set A, the full circle, it also contains 1, 2, 3, 4. Then set B. Set B, 3, 2, 3, 4, 5, 6. When we consider the B circle, 2, 3, 4, 6. The 5 is not in that picture. So we will write the 5 in the outside of the separated part of the B. In C set, 1, 2, 4, 6. In the circle of C, 1, 2, 4, 6 are also available. So there is nothing to write. That is the pictorial representation of set. So these are the main and basic concept of the set and its pictorial representation. I think that all got understand about this. Thank you.